hear Professor Jordan's talk just now. Today I'm going to introduce to you about our newly set up a research center called Trustworthy Federated Ubiquitous Learning, or TrustFUL for short. Incidentally, a lot of the visions mentioned by Professor Jordan in his talk just now, we had some preliminary work going on here. So we can skip the introduction here. So today in my talk, I will mostly divide it into two parts. The first part, we will talk about some theoretical research in our research center surrounding TrustFUL. And I will also mention three deployment cases that we are currently working on in collaboration with the industry partners to show how these works could be making real-world impact. So here's an overview of our vision towards building a trustworthy federated ubiquitous learning system. So we divide it into two parts. Part of the research focuses on building trust with the users of the technology, where we look into how to incorporate the concepts of interpretability, fairness, and robustness into this whole framework. And in terms of enhancing how the technology could be applied in various application scenarios, we focus on improving its personalizability as well as transferability aspect. So later on, we'll talk more about how these things are being put together. And also, we have had some deployment efforts together with the healthcare industry as well as the energy industry to look into how to deploy part of the work. One of them is concerning the interpretability part. The other one is concerning the robustness and scalability part. So there are too many works to mention here, but I will make some highlights into part of the works that are most relevant to our purpose here. So in terms of building interpretable federated learning, what we are focusing on is how to enhance the aspects of supporting the building of incentive mechanisms by producing interpretable assessment of the contributions made by the participants of federated learning. So we divide them into different scenarios of federated learning. This one is concerning horizontal federated learning case, in which people are sharing data pretty much have large overlap in their feature dimension, but in terms of samples, they have different samples from different participants. So we have some work focusing on enhancing the efficiency of assessing the Shapley value, using Shapley value-based assessment to evaluate how much contribution people actually make. This is post hoc. Throughout the training process, this assessment is being made gradually, and we gradually realize how much contributions we can receive from different participants. Another aspect we are focusing on is joint bi-level optimization-based approach to jointly select both clients as well as the samples that clients locally hold. Of course, we don't really look at their samples, but we put the sample selection part into the client to be implemented in the client side, so that the client could make such a decision based on the learning tasks that we have on hand, so that they would know which subset of their local data would be most helpful for that particular learning task. So in that way, we move forward a little bit in terms of not treating each client as a whole, but rather looking into how we can select some subset of their local data in response to different changes in different tasks that require them to participate. In terms of vertical federated learning, we are looking, of course, vertical federated learning is a different situation compared to the horizontal one. In that case, you have very little overlap in terms of the feature space. For example, you have banks trying to build models together with the e-commerce company. They are required to have a large overlap in terms of the client population, so that they can leverage the overlap in the clients to build models together. So in this case, the most important thing that we want to find out is how important each of the features that the clients hold they are towards the learning task they are trying to build. So in this case, we have built a dual gate-based vertical federated selection approach here, which we use gates to open and shut off some of the features that each of the clients contribute towards building the final model. So we gradually do this through training. Eventually, of course, once you decide which features you select and which features you leave out, you can try to convert that into some sort of an assessment of how much contribution each client is making towards the final model being built. So in that sense, this could be a useful technique to help vertical federated learning cases to make an assessment of the client's contribution towards the final model. In terms of fairness, we have a lot of definitions of fairness, a lot of notions of fairness involved, which would inspire a lot of research in this domain. But I just want to highlight one thing here, which is quite unique in our pursuit here, which we are focusing on the problem of free rider. And this problem was realized through our interaction with the banking industry in Singapore. We have 3 main banks in Singapore. At one time, they were trying to approach us to see how they could build the federated learning-based approaches to help them enhance their operations. And there were successful cases in terms of building fraud detection models together through federated learning. But once they are starting to move into money-making machine learning tasks, like, for example, how much loan we should decide to loan out to small and medium companies. And the companies, the banks, they have this new concern, because according to the classical federated learning training approach, like federated averaging, once you, throughout the training process, everyone would eventually receive the same model, regardless of a contribution in this process. And the banks, they are not happy about this. Every bank believes they are the leading bank in the industry, and they have a difficulty answering to their board why they are helping their competitor to build up their models. So they want to have a new approach that ensures that if they participate in such a training process, they don't receive the same model in the end. Rather, they would receive a model that would help them improve their model compared to just using their own data, but still preserve their market leadership or their market sector, not helping their competitors to build up their approach. So in this work, we try to work towards that approach, towards that goal by building this new training protocol here. We divide it into 2 processes. In the first stage, we try to build up the trust between the nodes in this network through a differential privacy-based generative adversary neural network. We try to generate what essentially is a name card for each person's data, and we exchange this name card so that this would pairwise they could perform some trainings together to assess the contribution from the other party that they're receiving this name card, and they can do this with each of the participants in the network. Normally, there are not too many of them. And then they can build up their own local version of the trustworthy, the trust they have towards other parties. Then they can start to make decisions on the second stage, where they can look through the list to say, okay, who do I trust? And I can contact the party to say, do you trust me enough in exchange so we too can build a federated model together? And they can do this with through their list until they don't trust the people lower on the list anymore. And when they stop there, you roughly have a model that reflects how the community assesses the value of your data. And
what prevents me from being trustable in Epic 1 and not trustable in Epic
2? That could be a part that we are continuing working on that, and because there is this problem, because whenever you involve the assessment of trust, you always have problems where people are not really, you have to have some verifiable federated learning approaches to complement that, to see whether they are following the protocol faithfully or not.
Well, they should be incentivized to follow. I don't think it's necessarily auditing mechanisms, right? I mean, a good auction will incentivize you to tell the truth.
Yeah. There could be other approaches as well, and later I'll also talk about our foray into the incentive and auction part. In terms of building robust federated learning training approaches, I highlight 2 works here, one concerning security, the other one concerning scalability. And for the security part, we want to build something that helps, because when people discussing about security in federated learning, you have many types of attacks, you have many types of defenses, and it is not going to be efficient to deploy all the defensive checks all the time. And we're looking into whether we can have any way to prevent a large segment of attacks without deploying a lot of the costly defenses. And in this work, we focus on the wireless federated learning scenario, where there is a wireless communication channel where people have to upload their models and download their models from the servers. And we try to protect that channel from external attackers by jamming the channel ourselves through covert communication-based approaches. And we formulate that into an economic problem with the assumption that there is a jamming service provider that we can employ. And we need to formulate a model that helps us determine when and how much do we pay to the jamming service provider and the jamming signal strength in order to protect our channel from this discovery by an attacker. At the same time, we can still train our model normally through this channel. So this is in this way we could protect a lot of the external attacks from happening, since they cannot really discover our channel in the first place. The other one is the opportunistic block dropout work for training ultra large scale models. And the large scale is not about number of devices involved, but rather the scale of the model itself. And we have this problem when we're working with Alibaba, and they have a few number of collaborators, but they have really big models. So in that case, we were looking into how we can divide a large model into semantic blocks. And the dropout would be performed at the block level, where we would determine whether the updates to each of the blocks are significant enough in each round of training to warrant that block to be transferred. And if not, that block is entirely dropped out, and we just inform the other party that you try to reuse the previous block. With this more aggressive way of dropping out, we can perform a very high level compression of the for the model that's being sent back and forth. And in that way, we can save almost we can cut down the communication cost by almost tenfold. And finally, in terms of the personalization and transfer learning approaches we involve here, we just highlight two words here. One of them is a combination between federated learning and graph neural network to look into a problem where the participants of federated learning, they are related by some kind of a graph. And we can leverage this graph information to, in terms of aggregating model for each of the nodes involved in the graph. And this would necessitate the use of bilevel optimization to perform this kind of learning. And this is in collaboration with Alibaba, where we're looking to how we can help them train personalized models for traffic prediction in their city brain project, where they deploy a lot of sensors in a very large scale traffic network. And in terms of the federated transfer learning situation, where it can be considered as a more challenging form of vertical federated learning, in which you have very little overlap in the sample space as well. For example, a bank in China trying to collaborate with the e-commerce company in the US, they have little overlap in the feature space and also very little overlap in the sample space. And we try to look into how we can leverage the non-overlapping samples by generating pseudo labels, by first projecting such samples into another space and try to generate additional pseudo labels to enhance the number of labels that can be used to transfer knowledge between these two domains. And of course, through this process, we also perform a number of surveys in some emerging areas in federated learning, so that it could provide some guidance for people interested in entering this domain in terms of personalized federated learning, verifiable, fairness-aware federated learning combined with graph neural networks, as well as the attacks and defenses of federated learning. So people interested could look into this. In terms of the translational research efforts, I could highlight two of the examples we we did before. So this one is a collaboration with pharmaceutical companies and hospitals in China. In that case, they contacted us to see, they have situations where pharmaceutical companies in China are trying to leverage data from the hospitals to build models to help them invent new drugs. And of course, for us, we would provide them with a service that help them determine how much contribution the hospitals would make to the final model, so that the pharmaceutical company could have some basis in terms of dividing the incentives to them. And you can see from the diagram here, the approach we try to deploy is the first one that I introduced for the interpretable federated learning under the horizontal situation. So we would help them through the training process determine the Shapley value-based contribution by each participating company. And through this process, for calculating the Shapley value, we have essentially generated a lot of sub-models in this process. And we could perform tests on these sub-models based on the test data sets we have in order to find out which sub-model performs the best among all these sub-models, so that we don't necessarily always pass on the entire model for each round of training. And we have built a deployed system here. I provide a demonstration link here. So if you are interested, you can find this information in our website and actually see the information that the pharmaceutical company could see. And for the second deployment case, we're collaborating with the renewable energy company, which has many factories involved. And we were trying to see how we could help them train large-scale fault prediction models through this process by deploying our block dropout approach. And through this process, you can also see here we have built a dashboard to enable the companies to manage this whole process and visualize what's going on, so that they can monitor what's happening. And the model being tested here is not really ultra large. It's about 30 million parameters, enough for their purposes. And throughout this process, you could see that we significantly reduced the time taken for them to train each round of update for the model, so they can update their models more frequently in response to the new types of faults that they discover. Because in this process, they actually would place a very tight limitation on the bandwidth that's allowed to be used for the purpose of training federated models, because we cannot make use of the entire bandwidth and disrupt their normal operations. And finally, we are working together with the Open Islands Initiative in Shenzhen, which is aiming to build a data exchange platform based on the idea of federated learning. So in that case, we would try to see whether we could support the crowdsourcing of federated models. Meaning anyone who has a need for federated learning models, they could initiate the federated learning task. And what if we place this in a network where nobody knows everyone, so that they would still need to go through their acquaintance network to dynamically find out who are suitable to participate in their federated learning task. And through this process, this would actually help us build a platform to study how incentives could be designed in this process, where we need to incentivize two things. We need to incentivize people to help us find out who are suitable, who are trustworthy to participate, and also we would actually need to incentivize those who help build the model itself. So this platform is in a test bedding stage, and the link is up there. So if you are interested, you could take a look at the demo video as well as try out the link yourself. And we have some books published on this topic, and this year another one is coming up based on our workshop in Ichikai, and we are trying to determine a theme on the new book as well. And over the years, we have also we have participated in the building of federated machine learning standard. This one was the first one, not really focused on the trustworthy aspect now, but laying the groundwork of how federated learning models should be built in industry applications. We're still trying to propose another one, which is more focused on the trustworthy aspect. And finally, we have a number of workshops organized over the years on the theme of federated learning, and new ones are coming up. Hopefully, if you are interested, you're all welcome to join us. Thank you very much. Any questions? Yeah.
So for the Shapley value calculation you did for the contribution assessment, what test data, like on what data was this evaluated?
The test data, they would pass, you can see in this exchange diagram, the test data actually stays with the pharmaceutical company, and they would perform the testing pass on their part.
But how do you know?
But
we want to use that to reward. How do you know that's the correct
because in our deployment case with them, they don't want to pass us any data.
No, I know. That's exactly my point. Meaning that one way is I keep the data and I say this is your contribution.
Yeah.
But then you don't know.
Yeah, that's potentially could be a problem.
Yeah.
Because this is a three-party collaboration. We are not allowed to receive any data.
If they release the data, everybody trains on the data.
Yeah.
Right. So you can't hide it.
It's a kind of an auditing-based dilemma where the auditor would not want to release the auditing data, and the party being audited, they won't want to copy their model to you so that they can audit. They can have a copy of their model. So there's could be some kind of a problem there.
Yeah, we're looking at some zero knowledge proof for that. I mean, that's the type of thing you need.
Yeah.
It's kind of what it's difficult. I mean, if the model is large, there is no ZKP for large models. It's kind of maybe if it's simple model you can do. But that's the problem. Also, is your approximation that you have, is it reasonable? Is it far from the exaction?
There is some difference between the canonical one, but it's still within a reasonable range.
I need to hear a little more about that because it's an exponential calculation. So what do you mean within a reasonable range?
We were only able to perform such calculations within 20 participants. Any more than that, we're not able to do that. Yeah. Luckily, the collaboration involves only 8 hospitals, so they are organizations, so they're still within our capability.
Very impressive work. So it sounds like in a lot of the financial applications you're looking at, the participants have conflicting incentive.
Only if you are from the same industry, all of the banks.
Exactly. So how do you deal with that?
Sorry?
Do you have ideas how to deal with that?
Currently, no, because although we have some models proposed that could potentially solve their problem, but they are still not really adopting it, because they still part of the reason is because they don't really understand the technology as well, and also they have a lot of difficulty convincing their board in terms of making such a decision. Once we reach this level of collaboration among companies, most of the time the decision is not made based on technologies, based on a lot of other considerations. So we have some work in that domain, but we were not able to deploy them with the banks. Thanks.